He says you cannot go into 239.
Okay, I think that works then. All right, today we're going to be talking about our.
This is from last week.
Oh, no, I just forgot to change the date. I took some of the slides.
You didn't put all your up yet, right?
Last week's, no, I don't think I have.
Yeah.
I will get that done today. Okay, so last week we covered some details regarding the QTL formats for how to use the map data and genotype data to put it into this program. And I talked about how the format that I've been using is the comma delimited, and that's how it will come formatted out of our script that I have. So this was the example of what that CSV format looks like. We have the columns of the phenotypes at the beginning, and then the columns of the marker genotypes following. The map is in the second and third rows, and then the genotypes match whichever individual this is. Our QTL doesn't necessarily need the individual names, but a single individual needs to match the phenotypes with the genotypes of all these markers across a single row. So just to first discuss using R a little bit, some of the very basic stuff. R is a programming language. So you type in the commands similar to what we have to do in Lep-MAP, but instead it's able to use an environment that's called RStudio. And RStudio is a program that makes it easier to use R. And that's the program that you actually open when you go to use R if you have RStudio installed. Using R, generally you can use existing scripts and existing functions, or you can write your own. Using something like RQTL, all of that has already been written. You just have to go in and find the functions that you want to use and put in the correct information required by those functions. You can access all sorts of different collections of functions through what is called a package, and packages are published on the internet. You can find a package to do pretty much anything that you could think of in terms of accomplishing things in R. So just a few basic terms. When I refer to variables, a variable is how you actually store data in R. And the notation of that is you would assign a variable name at the beginning of a line of text. You would have the less than sign and then a minus to kind of form an arrow pointing towards whatever the variable name is. And then you would have your actual data on the other side of that arrow. And so, for example, if we had a variable that we wanted to name, if we wanted to create a variable named temp, and we wanted to set the data housed by that variable as a 2, you would say temp, the arrow, and then 2. And then whenever you type in the word temp, R would recognize that as the data that is stored in it. So if you did temp plus another temp, that would equal 4 since it's 2 plus 2. So for scripts are just a text file that contains a successive list of different R commands. It's one way to organize all of the work that you've been doing, that you do in R. And you can use functions within a script. You can use variables within a script. But it's just generally the way that you save the text that you use to work in R. To define a function is just a set of statements that are organized together in a more organized manner than what a script is, and they accomplish a specific task that that function has been designed for. So specifically for functions, the notation for functions, which is always the same, at the beginning of the line, you'll have whatever the function name is, followed by a parenthesis. And then within the parentheses, similar to how Excel formulas work, you'll put all the parameters within those two parentheses. And figuring out what those parameters are, usually when you're typing out the function name and you start the parenthesis, it'll pop up similar to how Excel does with the different options that you can enter. Alternatively, you can also use a question mark in front of the function name, how it's depicted right here. So you put question mark, function name, and then an empty parenthesis, and that'll pull up kind of a document that describes that function, how it works, what the different parameter options are, and even sometimes an example of how to use that function. The parenthesis can be used for before any function. It doesn't matter which one it is, who's created it. All published packages comply with this like notation of using the question mark to bring up a help screen. Additionally, most packages that have been published have what are called vinaigrettes, or I'm saying that wrong, vignettes, I'm not sure how it's typed here. But basically it's just like a long document compiling all of those different help pages for all of the different functions that are housed within that package. And those can be found online usually. And they're helpful, especially like for the R QTL package, to know what all the different options are as far as running the functions for QTL mapping. Another thing to clarify, when a pound sign comes before a line of text in a script, R will ignore it because that's how we comment things out in most types of languages. And so R ignores everything that comes after the pound sign. And it's helpful for just putting notes within the text of how to use different things. And I'll show you what that looks like as we get into looking at the R script that I have for converting the Lep-MAP3 data. And just another note, if anybody's interested in learning more past this about R, there's a package that I've used called Swirl, and it takes you through learning some of the basics of R within the R environment. And that's the URL located at the bottom of how to find more information on that package. Okay, so for the R script that we're interested in, I have the script that I've referenced. I've named it Lep-MAP underscore phased genos underscore naming. That's just because it takes the phased genotype data from Lep-MAP and it assigns all the names to the data, and then it finally converts it into the RQTL CSV file format. Some important points about working with this script specifically. You must set the working directory, similar to how we set the directory that we're working under for Lep-MAP. But this is using a path object that I've defined that points to the location of the file. And additionally, if you're working in Windows, the slash dividers in the URL, which I'll show you in just a second, are opposite from how you copy it in Windows. So always make sure to match the example that's listed there in the script. And I'll show you what I mean. Okay, so what I was saying with comments, I put in 3 pound signs. That's just because it makes it a little more apparent. I do 3 pound signs for like notes, and usually just 1 pound sign when I'm commenting out code that I don't want to use right now. But what I was saying with the path, right here, is that big enough or do you want me to zoom in?
If you can move in. Oh, good. Thanks. Yeah, that's helpful.
Okay, so I was saying you have to assign the location of the folder that you're working out of to the path variable. And that's what this looks like. So just like for Lep-MAP3, I like to just copy and paste so you don't have to worry about messing stuff up. So I'm gonna go to the example folder that I have created. And this has the files, sorry, that's small. This has the files that are output from Lep-MAP3. It has the original VCF file, it has a HapMap file, and it has a phenotype file. Another thing, these names all need to be standardized, otherwise they won't work in this script. And I've made a note at the top what those file names need to be. So the file .call needs to be named like that, coming out of the first what's it called? The first module of Lep-MAP. The parent call 2, that's what the module is called. It needs to be file.call. We don't use some of the intermediate files, so I'm not as concerned about those, but the file that comes out of the ordering 2 module needs to be order file.txt, and then the file that comes out of the final .awk script needs to be named output.txt. Additionally, the pedigree needs to be named pedigree.txt, and the folder needs to only contain a single VCF file. That's just because some of how I have this set up, if you have multiple VCF files, it won't know which one to choose coming out of that file, that folder. Let's see. Okay, so back to this path. I have some examples up here of other paths that I've been using, so I'm gonna write over this one, and I'm gonna paste that location that I had previously. And if you look closely, these slashes are right-leaning, while these slashes are back-leaning. And we need to change those to match this notation. Otherwise, R doesn't understand that it's a URL. So I just go through and change them. And this needs to be in either single quotes or double quotes. I usually use double quotes, but it's not gonna really affect it if you use single quotes. And so additionally, excuse me, you need to run all of the stuff in this script. So what I was talking about packages earlier, VCF-R is an example of a package that I use to open VCF files in R, hence the name. In order to open that package and access the functions that are located within it, you have to run this library function to access the function library.
You have to download VCF-R.
Yeah.
To recognize all the
And how you download different packages, if they're housed within kind of the database called CRAN, which is capital C, capital R, capital A, capital N, you can download them within the R environment. So I just put install and it starts to show stuff up. So install.packages. And then like I was saying with Excel earlier, it gives me some instructions. So I can enter the package name. And then when there's stuff already listed after the equal signs for some of these, that means there's defaults already designated, and it's pretty likely that unless you know you need to change it, you don't need to change it. So I just need the package name for this install packages function. And I'll put that in parentheses, or not parentheses, double quotes. because it needs it as, I'll explain in a second. When you put things in double quotes, R recognizes it as like text. Whereas when you don't put it in quotes, it recognizes it as an object or something that R can reference that has like a data value. And once you install a package, this VCFR can be recognized as like a variable that contains information in this sense of functions that would be additional like script stuff. But before that point, it needs to recognize these letters as text rather than as a variable. So this top part that you see with all the text, that's where you can type in different information and make edits and stuff. And if you put your cursor on a line and hit Control Enter, it runs that line. Alternatively, you can also type down here. I could type, I don't know if you're gonna be able to see that. I could have typed down on the bottom in the corner, I could have typed install and the same thing, and just hit enter a single time, but that doesn't store the work that I've been doing. If I put it up here, I can save all of this text to run at a later time. So generally it's better to work from, this is called the console, or no, this is called the console. It's better to work from this top box versus the bottom box. I consider the bottom box to be more like scratch paper. If you want to try something, see if it works, you can put it down there, but it's good to copy it and put it on the actual document in the top. So
Lisa, do you try to, identify the QTL through R, right?
right now, we're just going through the script that takes the Lep-MAP data to the RQTL format data. You need to do this step before you can use RQTL. Okay, so we've installed the package. Once you have the package installed on your computer, you don't need to run that step again. And so I'll run the library VCFR, and it runs down here. So it's showing me I hit enter on that. It ran this code, and this is the feedback that it gives me for that function or for that package. Okay, once that's been done, we can run our path information. And I said you can put your cursor at the beginning of the line and hit Control Enter. You can also highlight all of the script that you want and do Control Enter, and it'll also run that. That's useful when you want to run big blocks of text. So I could highlight like all of this information and do Control Enter, and it would run all of it versus rather than a single line. Okay, so we defined the path that had all of our, this was the path that had all of our files that came out of Lep-MAP3 and a phenotype file. After that, we use this set working directory. This is a function, and it uses the path that we've assigned to actually set what the working directory, where the working directory is. We'll run that, and now R is working out of that folder. If I would save something from R, it would save it into this folder. And so next, a lot of this script is reading in different files. Like for example, this is the VCF file. This read.vcfr function is used from that package that we talked about earlier. Some of the other ones are reading in the genotype data and the order file and the output file and the pedigree file down here. An important thing, if for some reason the VCF file isn't getting read in with how the script is typed, I've put an additional note like right here that if you can't read it in using this, you can manually put whatever the file name is at this location. And that should fix the reading in problem. And I've tried to put some descriptive headlines above some of this code. So after we read in all the files, a lot of the process is similar to how we accomplished it doing, the steps are similar to how we accomplished it in Excel. It's just doing all the work and saving all of the intermediate files in R, and we only get the final file as an output. And it's easier to apply it to lots of documents. So at this step, at this step, the script is assigning all of the different linkage groups a different number so that we can distinguish between them. And it's accomplishing that by finding which marker positions in the map are 0. And so if you have a centimorgan length of 0, you'd expect that to be the beginning of a linkage group. And so we can make that assumption. An additional.
So the 1 and 2 in the parentheses, those are the from the genome file.
Up here.
That's the column.
This is, I guess that's a good point to make. The Geno object or Geno variable came from the output.txt file, that final file that we get out of Lep-MAP that has the 1s and 2s in the different boxes. And so, in this, I have decided to do my numbering for the linkage groups at this step from 20 to 39 instead of from 1 to 19.
So 1 and 2 is for 2 columns?
1 and 2, R always organizes it. If we're thinking about the Geno file in like an Excel file, the brackets tell us which row in which column. And the first number before the comma is always the row number. So this would be row 1. And then after the parenthesis, you define what column it is. So column 2. I can actually run this and show you what the Geno file looks at that step. Okay, so I've run the script above this and I can open it. I need to go up, I should have.
No, but that is the array, right? So supposing you say the first column.
And we can view the Geno file in this, a different tab. It shows up if you click on it over here. But so row 1, this says 7, ignore that. It's just the first row. Row 1, did this run all this? Let me check. 1, 2. I copied the folder, I copied the folder that I used for the last workshop. And so this output file actually has some edits in it. And so it doesn't look like it's supposed to. And see, we'd run into this issues with this file because row 1, column 2 has this stuff in it, but we're actually trying to assign information to this file. And that's why it's important not to edit.
Second step. So this is not, so this is just exact of only one step. It's an array, right? So it's not a whole thing. It's only first row, second.
No, okay. This right now I think is a data, it might be a data frame. That is the type of variable it is. And data frames and matrix are pretty much exactly like Excel tables where it's rows and columns. And you can reference similar to an Excel, in like an Excel function, you type like A2 or like B1 or whatever.
Yeah, but what a parenthesis, 1 is the first row, second is column, second first one is row number,
Mhm.
second number is the column number. So you mean that this is the second cell.
It's the intersection of those rows and columns.
But it does indicate only one cell or?
It just if you only put one number, it only indicates one cell. If you can, I don't know if there's an example down here. Like at this row or line 69, you see I have
Okay.
the bracket, an empty space, and then a comma, and then I have 1:4. That means the whole row, all of the rows in columns 1 through 4.
Okay. So each
So that
one-
would select all of the rows in those first 4 columns.
So they corresponding to 14, 1 to 4.
Yeah, 1 through 4, like all the way down the line. I'm gonna fix this file.
So you line 49 on the script that you are trying to only identify particular cell.
Yes, I want this specific cell, which I was trying to show you in this file, which cell that was. But this file has been edited, and that's why it's important not to edit files, because this won't work with this script. From the chat, yes. If the first column, or if before the parenthesis is blank, it will indicate all of the rows for the columns which you've designated. If you assign a number and then a parenthesis and then it's blank for the columns, that will mean all of the columns for the specified rows. Let me fix this file. Let me get the- Okay, and this has some extra files because I've already ran this script in here. You can rerun the script even if you have existing files, it'll just write over them, but I'm just gonna delete them. We have one VCF file. Oh, that's not a file I need. All of the names are left. And we have a phenotype file, so that looks correct. And now I'm gonna move that out.
So the 20, what that exactly means? So you mean a chromosome, they are 20?
Just 1 second. Okay. Now in this genotype file, we can see it looks like how it comes out of Lep-MAP. So we have the marker number referencing the file.call file that has the actual chromosomes and positions. And then in this chromosome column, it's all zeros all the way down the whole document. I don't know why Lep-MAP does that, it just does. But
They didn't assign the Lep-MAP didn't assign the.
it doesn't assign a number, but we can tell which markers start a new linkage group because of how it's organized. So the first linkage group was up at the top and it comes down. We have 82 centimorgans, 85 centimorgans, and then it changes to 0. And that indicates that it's a new linkage group.
So we will do this manually.
No, this is within the R script. I have defined that whichever row has a 0 in it, with the exception, I don't know if any of these are going to have, sometimes there's double zeros at the start, like 2 markers are at the same position, and that's a 0. And I would only count the first of those zeros. I don't know if we have them. I would only count the first of those zeros as a new linkage group. I don't know if we have any. I don't know if we have any double zeros, but like, for example, at this 88.029, there's 3 markers at that same position. That can occur at position 0 at the start of the chromosome. And I would only want to count the first marker as the start of the chromosome and not have, because if you didn't, and this was also 0, without defining only take the first 0, it would count this as a linkage, this single marker as a linkage group, and then this next marker would also be another linkage group in all of the.
So
But that's already built into the script. I'm just describing
yeah, so
what it works, how it works.
For the Lep-MAP output, so the sending moment should be from the big number descend to 0. Right?
Yeah, it's in order. That file is in order. It goes largest linkage group stacked on top of the next largest on top of the next largest. It just doesn't have different linkage group numbers in that file in this chromosome column.
Okay, so could you go back your script?
Yeah.
Your 949,
Mhm.
the 20, what's that? Because the chromosome.
What this is doing right now is I'm numbering from largest to smallest. I'm assigning them linkage group numbers 20 through 39. I just do that so in case for some reason at a later step something doesn't get converted right, I can tell that that's a linkage group number and not actually the chromosome number. I'll use numbers 1 through 19 when we assign their true chromosome number. Right now, they're just getting numbered so I can distinguish between different linkage groups.
You will start 20.
I'll start at 20.
Instead of 1.
Yep.
Instead of 0.
And so this box, not this box, at the top.
So you mean you are able to assign 0 to 20?
Yeah.
Instead, you assign 20 to 39.
Mm-hmm.
Okay.
Mm-hmm.
Okay.
So this box will get a 0, and I just do that because it's the first box, and then I can start numbering
20.
from there. To describe what this actually does, it makes sure that makes sure that column 3 is stored as a number rather than as text.
So you start 20, so, and this increase number, right? You will absent the number.
Yep.
So you say the genome, third column.
I just want to make sure this is a number so I can detect what are zeros and what aren't zeros. If it's stored as like text, I would have to type in with quotes 0.000 and then it would recognize it, but I want it to be a number, so it'll recognize it as a number.
Okay, you say as numerical,
As numeric.
as character, so you both to character and numerical, they will recognize.
Usually it's good practice when converting to numbers, to have it store it as plain text first. So like as actual like text, not as a number. Because what I'm doing here is making sure nothing's stored as what's called a factor. And if you don't store it to plain text first, it can mess it up and not actually recognize it as what is actually in that cell.
The 950, you are trying to just save it in the.
Yeah, I'm just trying to save it as a number. Just make sure it's a number.
That's the whole row?
That's the whole row since I've left stuff blank. Yes.
Whole row, third column.
Mhm.
So you will go through it, and so if you will say the different like a plain text file instead of the numeric or character.
Mhm. Which it'll still look like this. Let's see.
Yeah. And
Okay.
they will
This is
recognize.
really small, but if you can see where my cursor is, it says column 3, character. That means that this is not actually being, like if I type in does row 1, column 3 equal 0. If I would put that in, it would say false. That is not equal to 0 because it's a character. But when I convert it to numeric, then it's storing it as a number. And if I put that same thing, does this cell equal 0? It would say yes, it equals 0 because it's
So more likely, every time you need to assign these things beforehand, otherwise they may not able to.
most of the time when you read, like If you have a data frame that you've created in R, usually that stuff will be correct. But since I'm reading in this file from an Excel file, a lot of the time it just stores everything as characters.
Weird.
Yeah, but that's so things don't get distorted. If for some reason you would want something as a number or as a character and it accidentally, it's easier to go from character to number than it is from number to character, as far as preserving the correct information. Okay, so after we do that in column 3, we can run this for loop. Essentially, it's gonna apply everything that's in it to all of the different rows.
So you mean I is a row number?
Like it would be similar to doing I equals 2. And then I could run all of this stuff, and I is a variable.
True, you mean like a row 2?
In this instance, it is because I'm using it within the brackets. And so it's telling it exactly what row to use. But it's better to do this I in 2 through number of rows in the genotype
So
file.
that means the second row and the whole column. No, okay, second row whole sheet and number of row genome. So what that mean? All the number in your file.
For loops, it doesn't do it all at once. It does it each number at a time. So it'll go through,
Things like work.
it'll apply, it'll change I each time as it runs it. It'll start at 2, then it'll change I to 3.
2 is the second row, second.
Yeah, and I just say second row because the first row was assigned to 20 already.
Oh, okay.
And so in this script, I is always the row number.
So what is the, so the,
All the for loop does is it changes I. It'll run it once
Yeah.
and I will be a 2. It'll run it another time, I will be a 3.
so they will go like the 2 and then number of rows, so every.
And it'll do that the number of times, like the number of rows in the genotype file is 2,504. So it'll do these functions in here, it'll do them 253 times.
So they go to row, they read a row first, and then they go refer to every single column.
Yeah, it's basically a way to apply functions and stuff to each cell at a time, since I've defined the row numbers for these. And these if and else are used to define instances when you want to do something. So it's saying if in the genotype file, row whatever I is at that instance. So if it's 2 at the very first iteration of this loop, it'll be genotype 2, 3. And so in genotype file 2, 3, that's this position for centimorgans. If this is equals 0, which it doesn't in that case, and so for for 2, 3, it would say false. Don't perform this step. It would go on.
You're a new linkage.
Yeah, that would mean it's a new linkage. Basically,
What is it for?
huh?
You say this is.
It does things as logicals. So like, is this statement true or is it false? And for row 2, genotype 2, 3, which would be this one, this is not a 0. So that statement is false.
Okay.
If we would go down to a new,
What the
That's how we
heck?
oh my God.
if we would go down to row 349, it would be like, it would come to here. It would say, in that statement, it would say 349, 3 at this position, that is 0. So that would get true.
True, so.
So it would perform this. However, there is a second, like true or false statement that has to be fulfilled here.
Uh-huh.
And this is basically just saying Gino I minus 1, which would be the row above,
So
it has to be greater than the cell that we're working in.
Okay, so you mean,
So that's saying this cell, 348, has to be larger than this one.
If.
But if I would have double zeros, if instead I was at row 350 and this was a 0, that if it equals to 0, that statement will be true, but we don't want a new linkage group. And so it would move on to that second part of the statement and see if this value is, or if this value is larger than this value. And if it's double zeros, they'd be equal to and not greater.
But
So
just in case if there are more than 1 0.
yeah, because that does happen sometimes.
Yeah, but can we see, how can we locate immediately? Because your number will be more than.
Yeah, okay. So if it's double zeros, if the row we're on is the second 0 of a double 0 start to a linkage group, this statement would be false.
Oh, because this one not greater than that.
And so if there's an and in here, meaning that both this statement has to be true and this statement has to be true. So if this one's true, but this one's false, the overall thing is false. And so it would not run, it would not run
Then you
this.
go else.
And then it would go to else. So what the else does is if the if function is false, it runs this in all those other instances. And so
If function is 4, then
it runs else.
they will go. If both fulfill both criteria, then they will run it.
Yep, if
And
the start and the end of the if statement are true, it'll run this, the highlighted in blue.
and otherwise,
In instances where this is false, it'll run else.
so that one become what?
The else,
The same thing.
the else means that the preceding cell, so if I is 2, we're starting out, 2 minus 1 equals 1. So Gino 1, 2, which was this, it's 20. The next cell would just inherit the value from the previous cell. So it's essentially doing that fill function like we do when we use Excel. If in the instances where we use the else function, this cell, because that's 2, 2, this cell would get whatever values in this cell, and it would just,
They will keep the same number as previously.
because there's the arrow, that's how you assign the values, and you can also do it in data frames and stuff like that. This value would just get put into this location.
So you mean if there are 2 0 consistently, so we assign the second one become the first one.
No, the second one just gets treated the same as if it would be like 0.1 or 0.2. It gets treated that way because we know it's the second 0 and not the first 0.
But with the sentence, where the script state, so you mean that's the L.
The else is run in all instances where this is false.
So
It's considered to be false even if this part is true and this part is false, it's false.
So it's I minus 1, which means the 1 cell
Above, yep.
So equal the.
It gets assigned into here. It's just doing like that fill step. When we're in Excel, we put 20 in the first one and we drag it and fill it down until we get to the 0. Then we'll add 1, like it'll go up 1 linkage group. So from 20 to 21, and we'll fill that down again. And that's exactly what this does, because if this whole if statement is true, it will run, this looks exactly the same, except there's a +1 on the end. So once we get to that next new linkage group, we'll take the 20 and we'll add 1 to it to make it 21. And then it'll keep going and doing that until it runs into a new 0. So that's assigning the different groups different numbers so we can distinguish them from one another. Okay. What all of this,
So you would, the output from this first portion is good.
I can run that and show you.
So become like a 20 and then up, go up to 39.
Yep.
Okay.
So I'll run that, that's done, which I just did all of the rows in that whole file, which is a lot faster than Excel. So we have 20. To 21. Right at that 0. And at the bottom, it should be 39. Or 38, since we're starting from 20 instead of 21.
But normally there are 20 chromosomes. So you will use the 19 or 20. So like for instance, when they try to classify you for the GBS, they give 20. A lot.
They assign a chromosome 0 for unmapped, like essentially unmapped loci. That's not necessary here because the chromosome 0 do have a place somewhere on the 19 chromosomes. They just don't know what that place is. And so when we do linkage mapping, it assigns those zeros to whatever the most likely location, which should be the like actual location relatively is. So you can have chromosome 0 markers on any of the chromosomes. It's just they don't know where they are on like the reference genome. So they assign it to 0. And so we should only have 19 linkage groups at this stage.
Okay. So you start 20, so they are only total exactly 19 0, most likely, right? Otherwise, they would not start at 38.
It's just because usually when we number from 1 to 19.
Yeah.
If we, yeah.
What I'm saying, they should be have the exactly 19 0 in the whole data state.
Yes, there should be 19 zeros unless there's instances of a second 0 for the same linked group. Okay, so the next step is extracting the chromosome and physical position from the file.call file. And the file.call file has been stored under this marker order variable. So I'll open that. And so that was just a list, remember, of the order in which the files are or the order in which the markers are in that VCF file. So we start off with the zeros because 0 comes first. And it's just numbered all the way down. And the genome file, these numbers reference the marker at essentially row 334 in this file. So that should be, I'm assuming it's maybe 7 or 14. 300 probably, no, probably 4.
This is a step function more like a lookup.
Yes, that's the same thing. In Excel, we would have taken these 2 columns and we would have put another column beside it with 1 through however many numbers there were in that file, however many rows. And then we would do the lookup for this column, and then it would spit out the information from this column and this column. We would have concatenated it previously, but it would output the chromosome and physical position. And that's essentially what this script is doing, which I don't know.
So the overall, and this only third column, right? The line, the script 64.
64. What I'm doing at that, so I'm doing the list of 1 through however many number of rows. That's exactly what I was saying. Like usually we would add a row that's numbered 1 through, how many is there in this? 2,507 observations. We would create a row that just has those numbers in order. And that's exactly what it's doing. So marker order column 3 Right now, column 3 doesn't exist, but we're going to put numbers in there. I'll run that. And now it does. It has 1 through the 2,500 and whatever, all the way to the bottom, and 7. And now we can, I'm subsetting the genotype file.
So the script 64, it just try to assign one column with corresponding to
Yep.
whole number.
So I can perform essentially the same thing, the VLOOKUP type of action. This is just subsetting the VCF or the genotype file because I only am concerned with the first 4 rows. This function,
So it means all row from the script 64.
or first 4 columns, sorry, I missed that.
Yeah, it's a 4 column, right?
Yeah, because this is all the information I need to get the names. And so I don't want to mess with the original genotype files that has all of this stuff. Let's see. Okay, so
So you,
this is going through all of the rows in, this probably should be subgeno. All of the rows in the subgeno file. And I've assigned that to be J. This can be whatever letter you want. It's usually pretty standard to use an I, but you can use whatever letter.
so you go to column 5 and 6.
Yeah, I'm going through column 5 and 6 in the subgeno variable don't exist right now. We only have 4. I'm adding information, and that is, so subgeno I, 1. So column 1, row I, this 429. That's what this whole thing would equal. That would be 429 if J is equal to 1. I want to find which row in the marker order file is equal to this 439. And that's what this does. This is a which function. It'll tell me, I'll just change this J to an I, or sorry, to a 1, since that's the first.
So that is the row 1, column 1.
Yeah, row 1, column 1 in this file, which is 429. I want to know which row in the marker order file, which is this one, is equal to 429, which we can look in here manually and find 429, which will be up here. So 429 should be, I believe, this is row 429, which makes sense. And so if I enter this which function, which has been applied to this statement, it should give me down here in the bottom 4, whoops. I can't scroll with the Zoom thing on the bottom. Okay. There we go. Okay, so it returns to me 429, which is what we expect based on looking at it. But we don't want to look at that value for every single marker in this data set. So we just use the which function. And then, so essentially I could change, I'll just take this out for a second. Since we know this is a 429, that whole statement could get changed to 429. And now we're extracting the information from the marker order file, row 429. Oh, wrong file. One more. So row 429, columns 2 or 1 and 2, I believe. 1 and 2. So that's 5, 390, 39, 3392. And that's the physical chromosome and physical position. And that's the information we want to extract from the marker order object or variable. And so that's what we're doing. Columns 1 and 2 from row 429. But in order to make that applicable to like all of the rows, you have to include that whole function so it can go through all of the i's, which is just all of the rows. It'll do 2, 3, 4, 5, 6, so on and so forth, extracting all of the appropriate chromosome and position information and putting that into this subgeno file in rows 5 and 6, which don't exist yet. So I'm going to do that. And this takes a little longer to run since it has to go through all that, but it's done already. And now we have the physical position and chromosome for all of these markers. And it's been filled all the way down this whole file. These, I just want to make sure that this subgeno 2 and what is it, 5 are stored as numbers. They should be, but just in case. If stuff is stored as characters when it should be a number, that can really mess up scripts. So I perhaps have more than necessary designations of that.
We just want to make sure they all become numerical.
Yeah, let's see, I went too far. Okay, so we did those two things. This next one, which this could be more appropriately, sometimes when I run intermediate maps, like not final maps, they'll have more than 19 chromosomes because I'm trying to see what the big groups are, like where they should belong, or those extra groups should belong. So I have it turned up to 52, but it could be 38. So that would be,
Just give a little bit more.
yeah, so it applies in case there are extra groups. But it could be 38 if we just have our 19 chromosomes. Because it'll go, K is getting assigned for all of the different linkage groups, 20 through 38.
How can
Change that back. But
how can my 73 then knew exactly what you were talking?
73.
Because the K is a variable you assign,
Mm-hmm.
but 22, 52, where can they find the information? Because we didn't assign anything. But
This step does that. It would be, because the for function doesn't do 20 through 52 all at one time. It does 20, 21, 22, so on and so forth. It would be the same thing as if instead I took this out and I didn't have it in a for, I'll make some space. If I didn't have it in a for function, I could do K is equal to 20, and I could run this, and then I could change K and do 21 and run this, and so on. But the for loop, instead of using the arrow, you just put the in, and that accomplishes kind of the same thing as doing it one by one.
oh, the in is a
The in designates what K should equal.
so leave the numerical.
Okay, what this is doing, I think we're still in organizing the chromosome and physical position stuff. So let's look at what that file is. Linkage group list is empty. So I'll get set K to 20 just to see what the first.
Hold on, so you were 74.
Basically,
Assignment become a numerical, and that is the second column.
I don't know why this isn't getting any
Called 20.
data. But okay, so the first part, which of these,
Okay.
which of these would be equal to K, which I'm gonna set to 20. And that's subgeno column 2. Oh, that's because I accidentally ran that step and it already reassigns it to 1 through 19. Let me just rerun all this stuff quickly. Okay. So the linkage group list subgenome, okay, 20.
Mhm.
That's the whole first linkage group. LG list, I think it's stored as a value.
So the 20 is the second column, so the 5, what does 5 mean? That is the fifth column,
The fifth,
line 74. So this is the second,
okay. This which statement, it's saying which of subgenomes column 2, which rows equal to 20. Basically, we want to get the first linkage group. And that's all of these numbers, 1 through 70, since it's the first one.
what's this number? This is the what?
For 20.
The,
Down here, these are all of the rows. So which subgenome in column 2, which of those equals 20? And these are all of the rows that equal 20 in the second column.
that's something which mean the first chromosome, right? You try to.
Yeah, so the first linkage group.
So what's the 5?
5.
Answer that immediately.
So this is 1 through 70. I'm going to, this could now become 1 through 70 for this 20. And so we see
What is 130? Oh,
the 1 from here. I just ran this 1 through 70.
so that's the chromosome, 1.
That's the first chromosome, which has been assigned the number 20.
So they are 170 markers.
Mhm. And so sub.geno, comma 5, row 5, 1, 2, 3, 4, 5. This, I'm going to extract what all of these equal. And they all equal 3 because linkage group 20 is actually chromosome 3. And so we're extracting what column 5 is equal to. And so linkage group list should all have 3s. And so I ran that and they're all 3s.
Oh, you replace these things in the column 5.
Yep. In instances where this was a loss filtered map, you would have maybe mostly 3s, maybe 2 or 3 5s, because there's some markers from chromosome 5 that have been incorrectly ordered onto this group. And we would see all of those. So we would have 3, a couple 5s, and a 3. Let me
Where did you assign 3?
undo that. Okay. I'm not assigning 3. I'm extracting the 3s from this column.
Oh,
The 3s from this column. And since they're all 3s,
oh, the 5th column.
the 5th
And then-
column,
Okay.
I'm getting all that information out and it's storing it to this list, linkage group list.
So actually, this is chromosome 3.
Yeah. Linkage group 20 is actually chromosome 3.
3.
And in instances,
It has 170 markers.
Marker.
mhm. And in instances where there would be some markers that were incorrect on that group, you'd want to make sure that you weren't using that as your chromosome number and you were using the more prevalent chromosome number. So I sort the linkage group list. Let's see, just a second. I'm going to make an example here. We're going to do list. That might be more. Numeric. We're going to make a really short linkage group. Maybe it only has this many, but I'm going to change 2 of them to 5. 2 of them in the middle.
Yeah, we probably should.
Oh, are we? Oh, yeah.
Yeah, we probably
We are
should
at time.
start soon because your web might come in.
Okay. Okay. We'll call that good for this week. Next week we'll probably pick off.
So next
here.
week, we'll go back to Tuesday, right?
Yeah, we can go
9 o'clock.
back to Tuesday.
Okay,
9
so, yeah, 9 o'clock, I mean,